Here are the answers for the week 18 Bowork, day 1, problem 1. Simplify the radical expression. Inside of a square root symbol, we have the number 128. That is not a perfect square. If you try to do the square root of 128, it is a decimal. So let's rewrite this by factoring the 128. We're going to think of 128 as 64 times 2. The reason I selected that way to factor it is because 64 is a perfect square. So in the next step, the square root of 64 makes 8. But this 2 remains in a radical. And then in the final step, these two numbers out front can be times together, 24 times the square root of 2. For question B, we want to take the cube root of a fraction. So to take a root of a fraction, you separately take the root of the numerator and the root of the denominator. The cube root of 8 makes 2. Next step, an expression is not simplified if there's a radical in the denominator. We need to rationalize the denominator. So times top and bottom by a cube root that will cause the denominator to turn out to be rational. What multiple of 5 can you think of that you can find the cube root of? The one that occurs to me is 125. So to change 5 into 125, we need to have a 25 here, and in the top to compensate. Now we have 2 cube root of 25 in the top, and in the bottom, we would have the cube root of 125, which is just 5. Day 1, problem 2, simplify the radical expression. So this is a lot like question A on the previous problem. The square root of 32 is not going to work out nice. So let's do some rewriting and think of 32 as 16 times 2. Now look at the letter x. This goes to the third power, and the power 3 is not a multiple of an index of 2. So we need to factor x to the third. Let's do it as x squared times x. And then we also have a single letter y there. Next step, the square root of 16 is 4, and the square root of x squared is x. Leave the other things in a radical. The 2, this x, and the y. Next, question B. I notice there's a negative exponent. So it's not simplified when there's a negative exponent. Let's fix that by rewriting it as the 5th root of 1 over k to the 6th power. Now I notice there's a fraction. So let's separately do the 5th root of the numerator and the 5th root of the denominator. The 5th root of 1 is just 1. After those work steps, we notice that we have a radical in the denominator. So we need to rationalize. We're going to times top and bottom by a 5th root of something. Let's figure out what we need to have in here. This power, 6, is not a multiple of that index of 5. What number that's bigger than 6 is a multiple of 5? The one that comes to my mind is a 10. So to make it be k to the 10, we have to times by another k to the 4th, because 6 here and 4 here would be a total of 10 k's. So now we have in the top the 5th root of k to the 4th, and in the bottom we will have the 5th root of k to the 10th. But the 5th root of k to the 10th is k squared, because the power 10 divided by the index 5 makes an exponent of 2.